Today I'm going to talk to you about continuous integration, continuous deployment or development. Deployment, or it's usually deployment or development or something on GitLab. And I prepared for this before the move to GitLab craze. So I'm not trying to stay relevant, just a coincidence. I've been using GitLab for quite a while now. So welcome, guys. Let's start with the beginning of the software. Previously, when people got into software, this is what I heard from Uncle Bob Martin, what he was talking about. So in the early years, the years of Alan Turing, people who got into programming were older people. They got people who were already in the profession of accounting. They got people who were already in doctors. Whoever was a professional, they got them and convinced them to be software developers. Anyone who was smart was convinced to be a software developer. Now, in that, these people were already organized. They knew what to do, and they had the discipline that they were for doing the job. So programming was a real job with real professionals, and the average age of a programmer was averagely 35 years old. So there was a lot of discipline in that. Then if you look at those older days, on the Mercury project, the project that landed people into the moon, those people worked in iterations of 6 weeks. So there was already the idea of giving deliverables within a fixed time. So the Mercury project had iterations of 6 weeks, and they wrote their code, their test during the morning, and made them pass in the afternoon and went home. This is what happened in the early days. All right? So basically in software engineering, there's nothing really new. We're just reinventing everything. Now, later on, computer was introduced into schools, and younger people got into computing. You know, young people with energy. So there was kind of a mess, and I believe there still is. What Uncle Bob says, Bob Martin, he describes it as a horde of young testosterone-driven boys who need discipline imposed upon them. So Winston Royce, the cool guy over there, in the 1970s, he technically came up with the Waterfall Model just to control how software can be delivered to customers. In the Waterfall Model, you plan everything from the beginning to the end. And that is basically how software was developed from late 70s up to around 2001, when some things changed. Now, the biggest problem in software is that it's hard for software developers to understand business and for business to understand software developers. You just can't walk into a business and tell them that you want to write tests. That is none of their business. But we need a way of doing our communication. So that's the problem that you normally have. And the solution for that was in 2001, a couple of software engineers met, or software developers, they met. Martin Fowler, Uncle Bob, and the likes, they met, and they summarized the problem and gave the bridge between business and software using the Agile methodology. Okay? Agile methodology is a brief, approximately 68 words. It's never a complicated thing. It's around 68 words that brings the connection between the business and the software. Okay? So all this, whatever I'm talking about, is leading us to how GitLab enables us to do all these. So Agile was born back in 2001, and so much has been done. You'll never go to a conference or hear someone talk about something and they'll fail to mention Martin Fowler, Bob Martin, or anyone else. So they at least redefined how we operate. Now, these are the principles of the Agile. The first one is that you must prioritize individuals and interactions over processes and tools. You have to prioritize working software over comprehensive documentation. You don't sit down for 3 weeks or 1 month writing documentation for software that's not there. Have the software out and probably have its documentation accompanying it at the same time, okay? So have working software. Customer collaboration over contract negotiation. It's good practice to involve your customer, who's your client, or in case of, if you're developing a software like, let's say, Facebook, you need to collect data legally or illegally. Sometimes they do it illegally. From the client, get feedback, then revert immediately. That's the last one. You need to respond to change. If a client is not comfortable with something, you should be able to revert immediately on that, okay? So all these principles are made possible on GitLab. The amazing thing is that they have all these made possible within one platform. If I compare it to some other, to GitHub as a platform, you are not able to do, let's say, run your test within GitHub. You need to have a third-party service like Travis CI, like Semaphore, that will run the test for you, then bring back the result of the test. Circle CI or whoever, bring back the result of the test, then GitHub through the webhooks will give you a tick or an X, okay? This is normally inbuilt into GitLab. I won't get into the details of all of them, but the next one I'll talk about is how do you respond to change? How fast can you respond to change? This applies to both, whatever you've used before. So I'll talk about continuous integration. Now, integration on GitLab, you have an issue board on GitLab integrated, okay, where you can use your issues. You can do merge requests. This applies to all, so not magic at all. The usual CI, that's supposed to be an emoji, not a black thing. Okay, it's supposed to be some cool emoji. I don't know why it's not working. Then you can have Slack integration onto your GitLab, okay? Now, our issue board on GitLab looks like this. This is inbuilt. You don't need an extra party to have this. I think Pivotal Tracker works great, all the others works great, but for the issue board on GitLab, it's easily integrated. If you want to close an issue, or if you create a pull request or a merge request, they call it merge request. If you create a merge request that is supposed to close, let's say, issue number 3, okay? If your issue is issue number 3, then you want to create a merge request that will close that. Your branch name can start with 3 dash, then whichever the name. That automatically ties that merge request to that particular issue. So if the merge request is closed, then that issue will move itself to the closed. So it's upon you to move your issues from the backlog to the to-do and to the doing. It's a flexible thing, how you want to move it. But the moment the merge request is merged in, it will be moved to closed. So it makes it as easy as that. The next thing I can talk about is the merge request. The most awesome thing I saw about merge request on GitLab is that while your continuous integration tests are running, you don't need to wait for them to be done before you merge. So you can go there and say that I've approved everything looks okay. If the test pass, then just go ahead and merge it. So there's a button that tells you merge when, test pass. So even if it takes an hour or 2, you don't really need to wait for that. The other thing is, I think I've talked about that. Reviewing servers. So for the reviewing servers, this is another awesome thing. For every merge request, when we normally work, we have to pull down the code, test if it's working, run the server on our local machines before we approve. That's how we usually work. But GitLab has some amazing way of reviewing the changes. You can review the code, the diffs on the code, but again, it can spin up a server for you for every merge request if you want. So besides every merge request, there'll be a link to a server that is running for that particular merge request. The moment that merge request is closed, then the server will be shut down. Okay, we're not able to do that. It's probably an enterprise thing, but I was able to read through that, so we were personally not able to do that. All right. The next thing will be talking about integrations. So for us as devs, when we work, you need to know when someone has pushed something, when there's a change, when there's a comment. So we have a notification channel that we work with. Whenever someone opens a pull request, you'll get a notification. If someone comments on a pull request, you'll get a notification. If your deployment passes, you'll get a notification, or if it fails, depending on what you want. The next one is /commands. The moment you do GitLab integration with Slack, then you have access to what you call /commands. So /commands enable you to, let's say, look at the issues from within Slack without going to the issue board. You can look at a specific issue. You can create an issue from within Slack if you do the integration. Then Mattermost is also another chat client, just like Slack, and you get all these abilities. Now, let's talk about the CI. So CI is, whenever you develop software, you need CI to make sure that the existing code does not fail because of the incoming new code, okay? The easiest way to do this is to write tests, automatic tests. Now, it's easier if you are a group of 3 to 5 people. Every time someone opens a pull request, pull it down, run that on your machine. The next person will pull that code down, run it on his machine. First of all, it takes time because everyone has to run the test and confirm that it's passing. Secondly, you might not, okay, it takes a lot of time. Let's talk about that. So for the CI to work, you need a dedicated computer to do the CI for you, to run the test. So this is a simple example of what you can do. So within GitLab, you can have CI being run for you, and GitLab uses Docker images for this. So what you need to specify is which image you want to use. So you tell it, I need image that contains Node.js 8.0. Then I'll be deploying to GitLab pages. This is the simple script that deploys to GitLab pages. Okay? So if you have a project, like this is a foundation project, it will get your project, npm build, run build, npm install, run build, then it takes whatever the result it is and deploys that to GitLab pages. I'll show you how that's done immediately after this. Now, let's go over to the deploy, okay? How do you actually do the deployment? So there's this cool way of doing your deployments using Kubernetes on GitLab. So they have, I don't know if it's a partnership or something, but it's now easier to deploy to GCP when you are within GitLab. But for now, continuous deployment on this. So when you write software, continuous development is when you write software that can be deployed at any time. If your dev team falls sick today, what happens? The software should be at least usable at that particular state. That's what continuous development or deployment is, okay? If you resume next week, you should be able to continue working from where you left, okay? So GitLab makes this possible for you. I was rushing through everything because I think time is bad, and I just had to include this. This is somewhere close to where we work. We can, we normally sometimes go there to relax. Thank you very much. That's my online face, okay? I know the talk was going like this, then all of a sudden it's now done. I was just rushing through, okay? All right, I'll be checking any questions. Then after the questions, I'll do a demo. Stability is the problem. GitLab has stability issues. There are times you can be pushing to GitLab and it won't go through. There are times you're trying to merge and it takes like 2 minutes or so. So they have stability issues. The good thing about GitLab is that they usually try to update you via Twitter. If you follow them on GitLab status on Twitter, they will be telling you in case there's anything. Whenever they have upgrades, you'll see a red bar telling you that they will be having upgrades. You might have a downtime of around 10 minutes as from this time to this time. So they normally do that. But my biggest problem with that is usually stability. Yeah, they move so fast that's just my opinion. They move so fast, stability is sometimes a problem to them. Because I remember some time back, they lost pull request. They lost all the data on the pull request and everything. So yeah, it's a gamble also for using GitLab. When you run tests, whenever you're doing your CI on GitLab, you have things called pipelines, okay? So you can have pipelines in parallel. So you can have a pipeline running your RSpec test if you're a Ruby person. You can have another pipeline running Cucumber test. You can have another pipeline checking for Robocop errors. These can run in parallel because none depends on the other, all right? And if any of them fails, it won't move to the next stage, okay? So all this is inbuilt into this. If the moment you describe your, right here, I think I need a Ruby one for an easy explanation, but that particular script, you can run Robocop there. You can have stages and pipelines. So for your pipeline, let's say you have the testing pipeline, just as I explained before. Have your pipeline running RSpec. You don't need RSpec to finish before you start on Cucumber. So all that can happen at the same time. Okay. Then the other good thing is that you can accept something to be merged even before the test pass. Just click on the button, merge when test pass. It will allow you to do that. Okay? Yeah? Nice question. So what you can do on GitLab, you can define environments, okay? So you can define a staging environment, a production environment, and your test environment, whichever you want it. So your staging environment, you can automatically deploy all to your staging environment where you can play around with it. I watched someone do this on GitLab. He's running on Kubernetis. Kubernetis has pods, okay? So he has like 10 pods, then he deploys to 5 of them to test out to users, but the other 5 still have the stable software, okay? Now, if everything works fine, then he will deploy still through GitLab Enterprise Edition, he will deploy to all the 10 pods, okay? So that's also possible. I just didn't want to include too much. A pipeline is, I can say, the usual pipe, okay? After you do this and that, okay? Now, for every stage, you have a job. The first job can be lint, check if everything is okay. The next one can be run all the tests. The last one can be just deploy, okay? Now, if you can go back, sorry. Okay, so this is how you define the jobs that you'll be running, these scripts, okay? I didn't define the stages here, but you can have them on different stages. So this is my linting stage, this is my testing stage, this is my deployment stage. For whichever the stage, you have the jobs, okay? So all these, the good thing about GitLab is that you have predefined GitLab YAML file that will do this for you. If you're running on Ruby, you can use the predefined one. If you want to deploy to Kubernetes, you can have that. I can show you that. Now, on the artifacts are downloadable things according to GitLab. So when you tell it, these are my artifacts, you're telling it this is what you should use to deploy to GitLab pages. Now, artifacts is, it's an interesting thing because the moment I read more about artifacts, it looked to me more like what OpenSUSE uses for creating ISO images for distributions. Whenever everything was okay, go ahead and create ISO images. This says that whenever everything is okay, go ahead and use this public and take this public, deploy it to pages. You can use artifacts to generate PDF reports. You can use artifacts to generate images. You can use it to generate anything, and it is downloadable through your GitLab account. If you go to your GitLab and for any pipeline that passed through to the end, go to the artifacts, you can download any of them. Okay? So that's a brief explanation of what this does, unless there's any other question. Yes, Stella? Kubernetes and Docker. So, Johanna, help me out. I think, this is what I think it is. Kubernetes is more like, I like using the word orchestration because I don't really understand what orchestration is, but it allows you to manage different Docker instances or images, okay? It's more like what Docker has for themselves is called Docker Swarm that is able to help you manage, but Google came up with Kubernetes that enables you to manage different Docker instances for you. I think that's a good explanation. Okay, yeah? Okay, the next thing I was to show, yeah, I did it, oh, yes. I'm able to do that. Services are, Ubuntu does it pretty well for you. It automatically starts the services for you. So anything that you need running for it to be able to, running in the background for you to be able to use it, like MySQL, as you can see. You can start, MySQL needs to be running for you to be able to connect to it while you're developing, okay? If you use a system like Ubuntu, then whenever you install MySQL, it will be started automatically for you. There are some systems that you need to explicitly tell it to automatically start. So on our Docker image, you must tell it to explicitly start this particular service to run on the background. For the Redis, Postgre, and the likes, then before script says that before I run any script, which is in line 19, please make sure that I have Reba installed and Hex sorted, then also install all my packages. Okay? That's what happens there. The next one, you can look at a Ruby one. I'll avoid Django. So, looks a bit complicated, but if you break it down, what happens here is you have the image in line 4, Ruby 2.4, the services, variables. When did I use a variable last? Okay, let's look at that variable. We'll talk about it when we come to it, okay? Now, cache, we've talked about cache. Cache everything under vendor Ruby. Then, before scripts, just make sure that you have Ruby installed. Install bundler. I don't know, I've never understood why bundler doesn't come with Ruby, because everyone who uses Ruby needs bundler ultimately. But I heard it was included in 2.5. So you have to install bundler every time, because whenever I get to a new project, I do bundle install, then I'm told bundler not found, install bundler. So every time you have to do gem install bundler. After install bundler, install all the gems. Then this is the first stage that you're going to do. You're going to lint using Robocop, okay? The script that you're supposed to run. Now remember that scripts are anything you run on the terminal. That's the easiest way to think about it. So for you to use Robocop, you normally do, you normally just write Robocop on your terminal. So that's what the script does. RSpec, the script is RSpec, then run all the specs. Now, if I remember whatever was happening here the last time, Rails. So if you, let's skip to the script section. Create DB, then seed, then run your test. Variables, database. I think this is what the Docker image uses to know where your DB is. And if you go up, this is what Docker uses to know the name of your DB, because every time you have to set your DB name and the location. I think everything is done. For the deployment, the last part, line 50. So every time everything passes, what we do, currently we deploy to Heroku automatically, staging, and you can also do staging to Elastic Beanstalk on Amazon. So for this particular one, on I think this is probably going to Heroku. But if you use DPL, DPL allows you to deploy to either of them. You can deploy to Heroku, you can deploy to Amazon, you can deploy to, I don't know which other service, but that's what I'm comfortable working with. So DPL is a gem by Travis, I think. It's a gem by Travis that allows you to automatically deploy. Kevin was working with that some time back, and I don't know, it might be the stability issues with the GitLab, because sometimes it just fails to deploy, giving you errors that you don't understand. Then when you rerun the job, everything works perfectly now. So it probably a stability problem. Okay, thank you very much, guys. I appreciate your audience.
Only heroes who present at this particular time. Only heroes, yeah? When people go out for break and they don't come back. Yeah. So thank you so much, Sigu. Give it up for Sigu once more.